Morning, everyone. Yes, my name is Alessandro Ciampechini. I'll be covering these next slides, and I'm an associate at WSP UK in the environmental team and the energy efficiency and net zero lead within the sustainability and climate change. I think if we move to the next slide, please, Andrew. Yeah, today me and Sophia are going to run through where we are 6 months on from the previous webinar around the challenges from the NHS around existing and new built hospital sites, and also all the challenges that need to be faced for those type of net zero projects. Just before getting into the slides, I wanted just to briefly mention some of the portfolio that we around delivering net zero at WSP, which usually it's a multidisciplinary project and approach. We got Royal United Hospital in Bath, where I'm gonna talk through in the next slides. But at the moment, for example, we are working in Leeds for a hospital for the hospital of the future, which is a new build scheme. For example, St. George's University Hospital, we helped them produce a green plan, and for example, Sussex partnership, we starting to work on a strategy to determine the best investment for new mental health work blocks. So having said that, I think most of you know WSP, and we're working a lot for the NHS around different streams of work, as you can see in the slide. So around strategic support, around utilities, buildings, and heat networks. So all of that is a very important part to the net zero journey. If we can move on to the next slide, please. Yes. Yeah, you can click it twice. Yeah, just to have it. Yeah. So in the next 3 slides, I think I'm just going to recap very briefly where we are and what are the NHS targets moving forward. I think the NHS achieved 62% in carbon reduction since 1990, which is good results if we look at the UK average of 45%. NHS England released at the end of last year a strategy to set out some targets and around the NHS. Of course, there are 2 main targets, which is one for the NHS directly controlled emission, which is net zero by 2040 with 80% reduction by 2032, and NHS Plus, which I'm going to talk through in the next slides, which needs to be achieved by 2045. So if we move to the next slide. Yeah, so just to give some background on what net zero is. Net zero is generally defined as a simple calculation that any CO2 emission annually are balanced by net zero carbon generation or offset. I think, of course, for the NHS and many other organizations, we need to look at scope 1, 2, and 3 emission. And as you can see in the slide, scope 1 and 2 are emissions which are directly controlled by the NHS. So, as you can see, there is electricity, gas consumption, facilities, fleet, and some waste as well. And then on the right-hand side, you can see, all the non-direct emissions, which is, patient visitor, for example, and all the supply chain for any medical services and providers to the NHS. So the NHS has set out some pathways, some trajectories for the direct and non-direct emissions. So if we move to the next slide, please. So I'm not going to go very much in detail, but just to explain where we are for the NHS directly controlled emissions. So we're looking at 6.5 thousand kilotons of CO2 emission at the moment, which, as you can see there, the top line is where it's going to go if we do nothing, and the bottom line is where we need to go to achieve net zero. And just around that, just flagging, around the direct emission, if we're looking at the buildings and the estates, for example, we can see that, around between 20 and 20% of that can be achieved by acting on the buildings. So this is just to give a flavor of that. And then if we move to the next slide, we can see how that goes up if we look at the scope 3 and the supply chain. So this goes up by nearly 4 times if we look at all of that. And of course, looking at that, the estate drops to between 5 and 6% of the total. So this is just to give a scale. So 25,000 kilotons means that we're looking at about the whole London emissions, just to make a comparison with that. So if we move to the next slide now, what I wanted to do is I wanted to present a real case, which it's on a project we're working on at the moment with the help of Sophia's team, the design team, and essentially it's Royal United Hospital in Bath, which is I think a typical example of the challenges faced by an NHS trust to be net zero across the estate, which means of course mostly existing buildings, but at the same time new buildings coming online in the next years. This site is 52-acre site, so it's a fairly good representation of a typical NHS estate in the UK. Of course, as I was saying, in addition to these existing buildings, which some of them are going to be converted or reshaped for their use in the future, new builds are going to be online in the next years, such as the new Dyson Cancer Centre, which will benefit from the new hospital program funding. And WSP is supporting the trust around creating an energy strategy for net zero by 2030, which again, as I was saying, that requires a multidisciplinary approach to have a good plan for that. So if we move to the next slide, please. Yeah, so the main message here, how we approach this project and what we looked at is essentially we applied a very holistic approach to create this energy net zero strategy for RUH, which of course means a very deep assessment of all involved around direct emissions on site. As I said before, this required a multidisciplinary approach because it's crucial to cover all the areas, technical and non-technical areas, to make a good plan and to not to miss anything on that. As you can see here, there are some macro areas of study that we faced, which of course carbon was key, of course, because we're talking about net zero, but at the same time we looked at the economics of the investments. So we put together some figures on how the economics work to achieve net zero on site. Of course, we took into account the strategic elements of any investment that need to be done on site. And of course, technical reliability and implementation of technical equipment systems is key as well, because of course we need to guarantee reliability of all the services for the buildings. And of course, the wider sustainability field has been taken into account, just making sure that all of that come together to have a consistent and a strong strategy and pathway for the future. So moving to the next slide, please. We can see all the areas that from a technical perspective we looked at. I'm not going to go in detail to all of them, but as you can guess, there are some areas that are very carbon intensive, like heating, for example, which, for example, by using steam and having a CHP on site, it's quite common across the NHS hospitals in the UK. So this was one of the areas to tackle in terms of carbon emissions. And I think the general directions is to go electric on that perspective by using heat pumps and any other electric systems. Of course, other areas of study has been the wider energy efficiency on site. So any actions, any project to reduce energy demand is the very first starting point to start with. And of course, we looked at Fabric, which usually is not an easy challenge to face and to implement, but of course, where is possible, Fabric was part of the assessment of the study. Electrification of the transport in terms of vehicles and charging points, and of course we took into we looked at energy that can be generated on site, which of course solar PV is the technology that's the most suitable for this site. If we move to the next slide, please. I wanted just to show you the trajectory of the pathway to net zero for a site like RUH, which I think, as you can see here, similar to the slides we've seen before, the top line is what's going to happen if we do nothing. So very much some gains in efficiency are going to be balanced out by some new buildings, for example, and then the bottom line is where we need to be by 2030, and then we extended it to 2050 as well. So as you see here, there are 5 main streams of decarbonization within the net zero pathway, which of course takes into consideration the grid emission factor decarbonization. So the UK electricity is much cleaner now compared to 10-15 years ago. Then, as I said before, the other stream of for net zero is energy efficiency reduction. So any reduction in demand that can be implemented on site is crucial to decrease your demand. And then there are the other 2 main components here, which is of course moving from gas boilers to electric systems like heat pumps, and at the same time tackle and solve the CHP carbon emissions with again electric systems and importing more electricity, which obviously should be green electricity from the grid. Of course, there's still, if we look at 2030 and 2050, there's still an element of offsetting. We need to offset some of the CO2 left, but the idea around this project, and I think in general for the NHS, is to minimize what needs to be offset. So the most we can do on site through site implementation, the better, and the more convenience. Of course, as I said before, within the study, we looked at the economics and the investments of each stream or each project, high level investment, I would say for now. But as you can see, we calculated some figures around what a pound can deliver to save an X amount of CO2. So obviously this depends on the technology, it depends on the project, but as you can see there, we came up with some figures which is between 100 and 150 pounds for 1 ton of CO2 which is going to be saved from now to 2050. So if we move to my last slide, what I wanted to say here again is that having a good pathway to net zero means to have a very pragmatic and realistic implementation plan. So what is pointless to have a very good, or in theory very nice, net zero trajectory, net zero strategy, but if that cannot be implemented, it's just pointless. So what we did, RUH, we put together a time scale for implementation. So of course, this starts with some quick wins on energy efficiency, renewable energy, solar PV, and energy management, metering improvements that can be done over the next 2 or 3 years. And then of course, the main project around fuel switch, obviously there's going to be some years of overlap as the implementation takes place, because of course upgrading a fossil fuel system to a fully electric system on a typical hospital, typical NHS site doesn't happen overnight. So this of course needs accurate planning and to make sure that all the services deliver when required. So the message here is that only proven solution can be implemented on critical sites like hospitals and in general NHS estates. So I think now I'll hand over to Sophia to talk about the Net Zero Carbon Hospital. Thank you.
Thank you, Alessandro. Can you hear me okay?
Yes.
Yeah, great, thank you. Good morning, everyone. My name is Sophia Wing, and I'm a Principal Mechanical Engineer for the Bristol Building Services team. So Alessandro has covered how you may want to approach decarbonising your existing estate and the emerging strategy for the Royal United Hospitals in Bath. And for the remaining half of our presentation, I will quite briefly expand on how we as a collective can ensure new capital projects will supplement that overall ambition to operate as a net zero NHS by 2040. So what does wanting to meet net zero carbon targets for a new hospital project mean? So it means we need to change our mindset, and we need to recognise that the built environment has a carbon impact, not just at construction, but throughout the building's life cycle. And when instead we start to consider both the embodied carbon from construction, the carbon emissions that are generated throughout a building's operational life, as well as future reuse or end-of-life disassembly, we start to get a true representation of the whole life carbon impact of a building and understand the scale of intervention needed to achieve a net zero carbon hospital. We pass on to the next slide, please, Andrew. So it's important to start thinking about the whole life carbon impact of a capital project from very early on, because it enables the client and the project team to drive down the associated carbon intensity in their design response. And establishing a strategy and project brief which identifies the need for a project whole life carbon assessment will support the delivery of a net zero carbon building. And it's a key way clients can ensure this is given the upfront attention and investment needed. So if we go on to the next slide, is not something that can be left to a specialist to respond to in silo. All design team members have a part to play in driving down the overall carbon impact, which would feed into then that whole life carbon assessment, as well as the wider project team. They'll need to be aware of the impact it has on procurement, design solutions, construction, scale of investment, and how materials are sourced as well. So just on that point around investment needed, there are projections in the region of around 6 to 12% uplift needed on new capital projects to respond to the net zero carbon agenda that we are aware of. If we go on to the next slide, at the last WSP Healthcare webinar, we were waiting for the net zero carbon building standard from the NHS to be issued, and we are still waiting for the document to be released in November. Therefore, the expectations around the NHS building's performance from a carbon perspective has not yet been formalised, but we understand it will identify the need to consider both operational and embodied carbon. So for operational energy, up to now regulated energy is evidence from Part L of the building regulations. However, its expected consideration of unregulated energy will also need to be assessed and considered. And then it's also anticipated the guidance will make reference to the various life cycles of a building with respect to an embodied carbon, with the need to monitor upfront carbon generated from project selection, as well as from construction processes. So this would include production of construction material and then transportation to site. So the unknown is whether there is an expectation to calculate the carbon intensity during the in-use stage. So this would include quantifying the carbon emissions from maintenance, repair or refurbishment, as well as end-of-life stage, which would consider the carbon impact of demolition, transportation to the disposal facility, and the disposal of parts within the overall assessment. If the NHS response identifies that we do need to consider in-use and end-of-life carbon, if we could just go on to the next slide and go through the transitions, Andrew. So this would then have to a lot of correlation to whole life carbon assessments of a building. But we'll need to wait and see the direction the NHS will take once the paper is released towards the end of the year. So why has embodied carbon become such a key consideration? Well, as an industry, we have a fairly good handle on operational energy thanks to Part L of the building regulations, mandating the reporting of regulated energy. And as an industry, we've become more effective at reducing operational energy by the selection of highly efficient equipment and looking at using alternative technologies such as heat pumps. And by doing so, proportionally, embodied carbon has a greater impact on the overall carbon, whole life carbon of a building. We go on to the next slide. So we anticipate some target or methodology coming out of the NHS net zero building standard regarding embodied carbon, but whilst we wait on that guidance, there are industry thought leaders on net zero carbon, such as the London Energy Transformation Initiative, who suggest, based on 2020 best practice, aspirations should be to reduce the overall embodied carbon for a non-domestic building by 40%. But actually, when you start to consider the time it takes to design and deliver these large capital projects, we probably should actually be setting our sights on the 2030 best practice, which is suggesting a 65% reduction against the estimated baseline. So we don't know how this may compare with the NHS targets expected to be captured in the building standard. However, what is clear from these figures is we're not expecting to eliminate embodied carbon completely, and therefore to achieve a true net zero carbon building, there needs to be some awareness around the need to offset residual carbon. If we just go on to the next slide. So to conclude, a true net zero carbon approach is to drive down not only operational energy, but also embodied carbon. And in response, a net zero carbon hospital will likely have the following attributes. You can see how here on the screen, just to generalize a couple of them. So building fabric specification is key, window specification, building orientation, and also overall glazing percentage area of elevations will need early assessment in the design process, as well as the proposed structural solution, which will have a huge impact on the embodied carbon of our buildings. And so therefore adopting modern methods of construction practices will provide that opportunity to minimise its impact. And finally, the need for more intelligent building services systems, which have greater digital connectivity to respond to user demand, and also the function of spaces will be critical. So all of this will, if considered effectively during the early design stages, will support that need in delivering a net zero carbon hospital. So yeah, thank you for your time for listening, and yeah, that was a very sort of brief overview, but I'll now pass back to Andrew for any question and answers.